The following scenario is hypothetical and presented for educational and entertainment purposes. What if Earth's magnetic field suddenly collapsed? At that moment, everything we take for granted, the protection from solar radiation, the stability of our climate, and even the technology that powers our daily lives, would be gone. With no magnetic shield to protect us, how would life on Earth fare in the face of this unprecedented catastrophe? The Earth's magnetic field is one of the planet's most vital and underappreciated features, often taken for granted due to its invisibility and constant nature. However, should this magnetic field suddenly collapse, the immediate effects would be catastrophic for life on Earth, as well as for the technological infrastructure that supports modern civilization. The Earth's magnetic field originates from the movement of molten iron and nickel in the outer core. This movement generates electric currents, which in turn produce magnetic fields. This magnetic shield, often referred to as the magnetosphere, acts as a barrier against harmful solar radiation and cosmic rays. Without this protection, Earth would be exposed to high-energy particles from the sun and outer space, leading to immediate and long-term consequences. The first signs: atmospheric changes and radiation exposure. The most immediate effect of the collapse of the Earth's magnetic field would be the onset of solar radiation reaching the surface in an unfiltered form. Solar storms, which are normally deflected by the magnetosphere, would now impact Earth's atmosphere and surface with full force. High-energy solar particles would begin bombarding the upper atmosphere, potentially stripping away large portions of the ozone layer. The ozone layer is essential for absorbing ultraviolet UV radiation from the sun, and without it, the Earth would be subjected to significantly higher levels of harmful UV radiation. These changes would have a dramatic impact on human health, increasing the rates of skin cancer and eye damage due to the intensified UV radiation. Furthermore, with the loss of the ozone layer, many ecosystems, particularly those in high latitudes, would be severely affected. Phytoplankton, the foundation of most aquatic food webs, would be particularly vulnerable, disrupting marine food chains globally. This, in turn, would have a knock-on effect on human food sources, especially in regions that rely heavily on fish for nutrition. Technological infrastructure, the breakdown of communication systems. Another immediate consequence of the loss of Earth's magnetic field would be the failure of communication and navigation systems that depend on satellites in space. Currently, satellites orbiting Earth are shielded by the magnetosphere, which protects them from solar radiation. Without this protection, high-energy solar particles would severely damage satellite circuits, rendering most communication systems non-functional. GPS signals, which rely on satellites to provide location data, would become unreliable, causing widespread disruption in transportation, logistics, and military operations. Air travel would be particularly affected, as pilots depend on satellite communication and navigation systems. As solar radiation increases, satellites could be disabled, and new satellites may need to be launched with enhanced shielding to survive the harsh conditions. Environmental consequences: increased earthquake and volcanic activity. While the immediate focus would be on radiation and technological failure, a more subtle and long-term consequence could be seismic and volcanic activity. The Earth's magnetic field also plays a role in stabilizing the planet's crust. Some scientists hypothesize that the collapse of the magnetic field could trigger tectonic shifts, leading to an increase in seismic events. The relationship between the Earth's magnetic field and geological activity is not yet fully understood, but the absence of a stable magnetic environment could contribute to changes in the dynamics of the Earth's interior. Increased solar radiation and global warming. The collapse of the magnetic field would likely exacerbate global warming. Solar radiation plays a critical role in driving the Earth's climate system, and without the protection of the magnetic field, the atmosphere would absorb significantly more solar energy. The increase in energy would likely result in higher temperatures, particularly at the Earth's poles. The polar regions are already experiencing the most significant effects of climate change, and the collapse of the magnetic field could accelerate the melting of polar ice, leading to rising sea levels. As the solar radiation would no longer be deflected, the warming trend could push many regions past critical thresholds for human habitability. In particular, tropical and subtropical regions could become significantly hotter, resulting in the displacement of millions of people due to extreme heat. The increased solar radiation could also disrupt atmospheric circulation, altering the pattern of global winds and precipitation. The disruption of weather systems. Another crucial change would be in the formation and movement of weather systems. The Earth's magnetic field plays a role in the behavior of the upper atmosphere, where solar winds interact with atmospheric gases to influence weather patterns. Without the magnetic shield, the solar winds would interact with the atmosphere in a more direct manner, potentially intensifying storms and hurricanes. Severe weather events could become more frequent, and new patterns of atmospheric instability could arise. Countries situated along the equator and in coastal areas would face heightened risks due to increased storm activity and the gradual rise in sea levels. As ocean temperatures rise, they would contribute to more intense cyclones and hurricanes, posing additional challenges to already vulnerable regions. Disruption of agriculture and ecosystems. The collapse of the magnetic field and the subsequent shift in climate would also have a devastating effect on agriculture. Plants and crops are already sensitive to changes in temperature, light, and radiation levels, and an increase in UV radiation would damage crops, particularly those in regions closer to the equator. This could result in a decline in food production, leading to widespread food shortages and famine. Ecosystems around the world would also face disruptions. As higher levels of UV radiation penetrate the atmosphere, plant and animal species that rely on specific conditions would struggle to adapt. Species that are sensitive to environmental stress, such as amphibians and marine life, would face an increased risk of extinction, further destabilizing ecosystems. While the immediate effects of the collapse of Earth's magnetic field would be catastrophic, the long-term consequences would include a significant shift in how humanity adapts to the new conditions. The question becomes whether civilization, as we know it, can survive and adapt in such a radically changed environment. Adaptation of human populations. One of the key factors in humanity's survival would be the development of technology to shield us from the increased radiation. Building underground cities or creating artificial magnetic shields could provide short-term relief, but these solutions would require significant resources and technological innovation. In the absence of such solutions, survival would likely depend on relocating to more hospitable environments, such as underground or within specially designed habitats equipped with radiation shielding. Humanity would likely need to abandon many of the coastal and tropical areas that are currently home to the most populous cities. As heat waves, storms, and radiation levels become more intense, migration patterns would shift dramatically. Large numbers of people could be displaced due to environmental conditions, leading to the formation of new, climate-proof communities. Technological innovation and reliance. Technological advancements would be crucial for long-term survival. It is likely that humanity would begin to rely even more heavily on renewable energy sources, such as solar power, since fossil fuels would no longer be viable in a world where natural resources are in short supply. Solar radiation, although dangerous, could also provide a potential energy source for communities with the right protection. Advances in radiation protection and bioengineering might allow humans to adapt biologically or technologically to the new environment, though this process would take centuries. The collapse of global systems. Social, political, and economic systems that rely on global interconnectivity would face unprecedented strain. The collapse of the magnetic field would lead to widespread infrastructure failures, including the breakdown of global supply chains and communication networks. Economies would struggle to adjust to the new realities of climate change, radiation, and resource scarcity. Global conflicts over resources might intensify, and nations would be forced to reconsider their approaches to governance and survival. In a world without a magnetic field, the survival of humanity would depend on our ability to adapt, innovate, and cooperate in the face of one of the most extreme environmental changes Earth has ever experienced. The future of humanity would no longer be determined by the old paradigms of technological progress and expansion, but by our ability to coexist with a planet that has suddenly become much less hospitable. Conclusion. The the future of Earth and human civilization. The collapse of Earth's magnetic field would represent an unprecedented challenge for humanity, while the immediate effects would be devastating, affecting health, technology, and the environment. The long-term consequences could change the way we live on this planet forever. The collapse of the magnetic field would force humanity to reconsider how we interact with our environment, our reliance on technology, and the way we plan for the future. Adaptation, resilience, and cooperation would be the keys to surviving in this new, unforgiving world.